All right, ethers. Ether, ethers I should say, and ether, it looks like this. It's an oxygen sort of acting as the middle of a chain. Okay, it's got an alkane chain on either side. They don't have to be the same. So for example, the most famous would probably be this one, looking sort of like a bat. Okay. This has, an ethyl on this side and ethyl on this side. So traditionally, it's known as diethyl ether or just ethyl ether. Okay, and that is the medicinal ether. That is to say, it's the one they use to knock you out when you go under, the dental drill or what have you. If they still do that, I don't know. The point is that that's traditionally ether, but you can have any sort of alkane chain on either side of that oxygen, and it would still be an ether. Ethers are kind of an odd duck. They never. Ooh, that's awful. They never have the suffix. Okay. So if it's ROH, then it's an alcohol, and you give it the suffix OL, right? If it's ROR, then it's no longer an alcohol, it's an ether, and it doesn't get the suffix. Instead, it's treated like a prefix group, like a halogen or any other alkane chain. It only gets the prefix alk, oxy. Okay, so you name the chain on the far side of the oxygen, and that's what I mean by alk. And then you say that it's connected by way of an oxygen using the oxy here. Okay, so let's go ahead and go through some examples. All right, here we have a chain. Okay, as always, you have to decide what the main chain is going to be, and it means you're either going to go by length if there's no suffix group, or if there is a suffix group, you just choose the one with the highest priority suffix group. So here we have one example each of our two suffix groups that we've learned so far. We have an alcohol on the left-hand side. We have an amino group on the right. Alcohols have priority over amino groups, so our main chain is going to be the one on the left here. Now, you got to be careful with these ethers. Remember, here at the oxygen in the middle, there is no carbon at these 2 points. No carbon. Okay. So here on the left, we have a chain with 1, 2, 3 carbons. Here on the right, we have our side chain with 1, 2, 3 carbons. So let's go ahead and name this side chain. It's got 3 carbons, so it's prop. That amino group is going to be a prefix because it's not it's not a suffix group. It doesn't have priority or anything, so it's going to be amino prop. That amino group is on the second carbon. Now we have a double bond that goes on the first carbon to the second carbon, so that's where that goes. And so it's prop 1 ene il. And then we have the heavier group is on this side of the double bond over here, and on this side it's over here. So they're both on the same side, so it is Z, 2 amino prop 1 eno. That's the side chain over there. So that's one side chain for this main chain. And the other thing we have on there is just the alcohol group. So we name this sucker as boom, 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 Z 2 amino prop 1 ene il. Okay. And then we need to say what carbon that's on. So boom, it's on the first carbon of the main chain. Prop and 1 all. So that is a pretty, oops, I screwed up. This is propenyl, there we go, we lose the ill. It's not, well, I'm going to go ahead and leave this whole thing in. It's not a propenyl, it's a propene oxy. So, oxy. Okay. So, yeah, that's my bad. If it didn't have a double bond, okay, I'll go ahead and give another simpler example next time. That's an example that's fairly complex. So 1, bracket, parentheses, Z, close parentheses, 2, aminoprop 1 ene oxy, close bracket, propan 1 ol. Okay, pretty big, pretty ugly. Let's go with something simpler. All right, here we have something with like no side chains, right? Right. Okay. So here we have 2 carbons. Over here we have 1, 2, 3, 4 carbons. So we just go with the longer chain to be the main chain. The other one will be our oxy group. So this is an F oxy. And this over here is just going to be a butane chain. 1, 2, 3, 4. Number it so the first time there's a difference, it gets the lower number. So that means that this is 1 F-oxy butane. So the oxy tells you that it's an ether. Okay, and the 1 tells you that the oxygen of the ether is attached to the first carbon of the main chain. And then on the other side of the oxygen, you have the F. Okay, so that tells you that there's just a 2-carbon chain coming off. So going back to the old standard, this is called typically just ether or diethyl ether. There's a fancy way to name this because it's nice and symmetrical, but I'm not going to go into that. The technical name for this, we just choose one of these at random. This is the main chain. This is the side chain. So this is F-ane, and this over here would be an F-oxy. So the IUPAC name, the standard name, the preferred name for this guy is ethoxy ethane. Now let's see if we can't find something that is a little bit more complicated without being hideous. Okay. All right. So, yep, that's a big one. So we kind of have our choice of 3 different chains here. We have the chain on this side of the oxygen, the chain going between the oxygen and the nitrogen, and the chain on this side of the nitrogen. Well, ethers don't get priority, so it's not this chain on the far side of the oxygen. Now, we get to choose between the 2 different amines, and all else being equal, more side chains is better. Now, the side chain in the middle, the chain in the middle would have 2 side chains, the ether and the far side of the amino, whereas the one on the bottom would just have stuff on the far side of the nitrogen. So we get rid of the one on the bottom. This up here is our main chain. So it's going to be a butanamine of some kind. This is our suffix group. Now we want our suffix group to have the lowest possible number, but, that could be either way. 1, 2, 3 coming from the left versus 1, 2, 3 coming from the right. We're going to have to judge it based on the side chains. There's only the one side chain coming directly off the main chain, so it's going to be going left to right. So what kind of chain do we have over here? Well, it's got 1, 2, 3, 4 carbons, so it's another bute. Notice that we've done the counting on that side chain to give the lowest possible number to the point of attachment. And we're going to do that, recognize that point of attachment the same way we would if it were just a butyl. But of course it's a butoxy, so it's but2-oxy. Okay. Just as a butyl group would be attached, the end of the butyl would be attached directly to the main chain if it didn't have a number. Same here with ethers. No number means that that side chain is attached. The end of the side chain is what's attached to the oxygen. Here we have but2-oxy to indicate that the second carbon of that chain is attached to the oxygen. And down here we just have an ethyl. Okay, so now we have our chains. This one comes first, this one comes second, just alphabetically. But comes before ethyl. So it is 1-but2-oxy in ethyl, propan 2 amine. And that's all she wrote. 1-but2-oxy in ethyl, propan 2 amine. So the ethers can make things slightly more complicated, but it shouldn't be, I don't think, anything too new for you at this point. You just got to remember, ethers never ever have priority. Okay? So they're sort of like halogens in that way. They are different from just throwing an alkane chain on there, but they never have priority. So they're always going to be a prefix group. All right. See you in class.